So hello and welcome to a new challenge, but probably not a whole challenge. So this one was from yesterday from Omid, the Every Other Day Excel and Power Query Challenge number 90, the so-called Traveling Salesman Problem, so TSP. You need to create a permutation there and then do a so-called two-dimensional lookup. And I will not do the whole challenge, so I could do the permutation generation. I also did this in 3 different ways when I solved the challenge, but I found this challenge is very cool if you want to learn how to do a two-dimensional lookup, and this is what this challenge in this video will be about. So two-dimensional lookups. So because we have a small problem here. You could assume so that if you want to search here for AA, you could assume, oh, we've learned something about how do I do an XLOOKUP with two criteria, as I've shown you in a video before. Also, I think we have a challenge for it. You could assume, oh, I do this like in like in two criteria lookup. So make both to the lookup array and then like this. But as you can see here, there's an hashtag value, so this will not work. And therefore, you need a certain technique to do a so-called two-dimensional lookup. I will show you in this video 3 methods I know. I will also link in the description the permutation generation. There's a cool video from Bodhi Excel Wizard showing how to do this. And I will also link a video from Darmut Early. He talks also about two-dimensional lookups. So, what do we need to solve this here? So we have a path here, and we need to first select, I call it like trailing chars, so that you have AB, the next will be BC, the next will be CD, then DE, then EA, so that you've every time 2 chars and only switch with every row or column to the next char. So we can use our standard mid, so like text splitting function. So we can use mid here, then sequence, len of all of this, nothing special so far. And instead of 1 char, we select here 2 chars. And here you have it. You have your path split it in 2 chars every time. And now you could use different methods to do an XLOOKUP here and two-dimensional lookup here. So first, you could use the so-called index function. Because with the index function, you select an array, so our output array, then you need to determine a row number. So what is our row number? We have here the different rows, and we could use a match function or the xmatch function. Look after, because in our after the left char here in this column to get the row number, and then look after the right char here in this row to get the column number. And as you can see, it's 26 because it's A and B. So what do we do here? So index, think of it like a coordinate system. You get the row number from 1 to 5 in this case, and the column number from 1 to 5. And the match function, or xmatch, searches, for example, for the B in this column, and B is the second char in this column. So we will do, oh, here the value needs to be here, and as A is the first char in this column, the row number is 1, and then we have it like like with coordinate system you've learned in school. And now to make this all happen, we need to map it here? I'll try. So we want to have a solution working for all. So let's use a let function, name this as P, and then no, we don't need to map it. So here we've inputted every time the trading two chars and have as a result 92 as it should be. Now we sum this all up. And we have 92, and we now map all those paths inside this formula. Lambda A, and not A, let's name it P for path. Put it every time here where we had that before, and as you can see, we have the solution. So it's a short way. The permutation generation was more complicated in this kind of challenge, but yeah, it's only to show what two-dimensional lookups can do. So there's also another method. We could use the XLOOKUP here. I will show you how. First, split the characters as always. Sorry, missed the len here. So here we have the characters, and now we do an XLOOKUP. But we look after the left character here in this array and return this array. And what do we get here? Oh, it searches after the A in this column, and if it founds the A, then it will hand out the whole row. And then we can do another XLOOKUP here, search for the right character here, only one, so only the rightest character, and as a lookup array, we use this whole row, and the output array is our pre-selected row. And here we have 26, as it should be. Because this is also not like index, but it works like the same principle. You first search for the row or column, and then in this column you will the XLOOKUP will hand out the position. So it's not like XLOOKUP, but it's more like the same. But here you have a problem. You can't do it that way, that you track this down. This will lead to an error. You need to map it here. So map also this chars here. Lambda C. And here you have the result. We can sum this now up. 92 as it should be. Here I will also bring this function inside this. Yeah. And now we also map the whole path here as before. Lambda P. Everything inside here, and the result is the same. Let's call this XLOOKUP. So you could also do something like, oh, I have a predetermined lambda for this. Mine is called 2D, how's it called? Lookup 2D lookup, L2D lookup. So, and as I've shown you how with the by unique lambda, I only need to give these this lambda the predetermined values. So here I need to AB, for example, L underscore 2D lookup. So return array is this array. The search area for the row is this one. The search array for the column is this one. Search criteria for the row is left from the chars here, and then right from the chars here. And our value is 26, as it should be. Now we can do, you can do like so. Here sequence len of here. I need to select it 2 chars every time that we have our standard array of chars. So this also works without a map function. I'm curious if this also will work without a map. Let's find out. Don't need the map here. X instead of C. Then lambda map will go out. No, this time not, but here this will work without a map function. I don't know if it could possibly be that it's included in the lookup, that I've thought about something like this. And now we map all the paths, the P, and now here our P should go. And as you can see, it's the same as before. So lambda BDA, yeah. So it's the same. 100. It's not the same. There's something odd, but I don't know why. Okay, let's deconstruct it. Sequence and then tried. It was a false flag with the standard example. It could possibly be that we also need to map it here. So return array, this one, who is this, row is this, column is this, and we need to search for left here, right here, and it should be 26. BD 31, but when let's check 31, the DE is 8, EC is 8. It hands out 113, but this didn't hand out 113. Oh, I see. I'm so bad. I haven't given them all the P's, so I've missed here. So now it's the same as it should be. So there's also a last method. It's to flatten this table and then do a standard XLOOKUP. So how do we flat this table? With toCall. So if you make this array toCall, it will go row by row and sends out everything in a column. So first this in a column, then afterwards this in a column, and so on, and all in one array. So we have our output array as a column. Now our headers. If you know how to create this array, that here's AA, here BB, here BC, you know that you can concat this with an AND sign, yeah, to get the letters here. And you could also wrap this into a to-call to get the description here for all the values in those in the output array. And now also split this again. It's a bit Omid. Split this again. Sequence len of all of this. 2 chars trailing. And now you could do a standard XLOOKUP after those values in this array for those values. And if not found, you could hand out a 0. So, and now we have also 92. And now we could also bring all those values in this function. No, sorry. So, and we could also use it here. And now we have it for one solution. Control X. Sorry. For one solution, we could also use the map function again here to map in all the paths. Lambda p. Now take a look that you replaced all the cell values. Oh, here we have a problem. Yeah, I think we need to map it here. It will not go that way. Let von split. Then we take out this function here, and now we map sp lambda a and look after a. Also calculation error. Huh. This is odd, but I don't know why. Let's find a little bit more down the road. Yeah. So instead of putting this in, I will map it here. The A. Yeah, this will work. And now we use this, this function here and map it then instead. So lambda A and A here. Sorry, no, I stay with P for path. Also calculation error, but I don't know why. I don't know why there is an error. Oh, I see. I'm so dumb. So I don't need the map here. But that's a bad error. But I need to sum this up, of course. So now we don't need the first map here, we only need one map. Lambda A, no P for paths. Put them all inside here. And now we have the values here. You could also use something like a pre-programmed lambda to flatten the table here. I have two lambdas for that. One who is a little bit, not so advanced, but this is quite advanced because it has a lot of optionality inside here. And you see it will also hand out the table here, but as you can see, there isn't a concatenation of the from and to values, so the flatten the table method we used here is a little bit more appropriate for this type of problem. So I've shown you all the different methods to do this kind of task. I've hoped you've learned something. I will link the other videos in the description, and I will hope to see you next time. Thank you for your attention. Ciao.